Picture this. Two teams at the exact same company are asked to build the exact same feature. They both need to calculate the average purchase amount over the last 30 days. Sounds simple, right? Well, here's the catch. They get two totally different numbers.
Section 1. The sneakiest ML bug. And it really is invisible. Nobody even notices this discrepancy is happening at first. That is, until the machine learning model actually starts making strange, totally inexplicable predictions in live production. It's honestly one of the sneakiest bugs in the field.
So, both teams absolutely think they computed that 30-day average perfectly. Yet, these two seemingly identical computations yield entirely different numbers. Why? Just because of subtle, hidden differences in their own private logic.
And you can probably guess what happens next. A single engineer gets pulled in, and they have to spend 3 incredibly frustrating days doing literally nothing but digging through code just to figure out why the model is broken. That's 3 entire days completely lost to a totally preventable error.
We actually have a name for this in the industry. It's called training serving skew. It happens when a feature is computed one way while you're training the model, but then slightly differently when you're actually serving live predictions. You know, the model was never technically wrong about what it learned, it just never actually sees the exact thing it originally learned from when it's out there in production.
Section 2. The feature store fix. The ultimate solution here is a feature store, which basically acts as a central repository for the complete life cycle of every single feature a machine learning model uses.
A feature store essentially gives us 3 absolutely critical things. First up, versioning and lineage. This lets us trace exactly which feature definition produced a given model. Second is point-in-time correctness. This guarantees your training data reflects only what was actually knowable at prediction time, so absolutely no information is leaking in from the future. And third, consistent feature definitions. This stops people from quietly reinventing things like average purchase amount with their own private logic ever again.
The crucial mechanism making all this work can be summed up in one simple rule. Same source, same math every single time. It means the exact same feature store serves both sides of the equation. Your training pulls its large historical batches from it, and your live inference pulls those exact same feature definitions in real time.
But a feature store doesn't just manage the definitions, it also dictates the speed at which that data moves, bringing us to Section 3, data speed and rulers.
Let's take fraud detection as an example. It absolutely needs rapid streaming ingestion to catch emerging patterns within minutes, simply because fraud evolves by the hour. But compare that to something like a weekly sales forecast. That works perfectly well on data loaded overnight in one big batch. And neither approach is wrong, but choice depends entirely on how quickly your model needs to see the world change.
To put it simply, without this synchronization, it's exactly like using 2 different rulers to measure the exact same wall. If one ruler is calibrated during training and the other is just recalibrated on the fly in production, well, of course the numbers won't match. You are never actually measuring the same thing twice.
Ultimately, if you get the feature store right, an entire category of these invisible, maddening production bugs simply stops existing. It fundamentally transforms the reliability of your models. So the question I want to leave you with at the end of today's explainer is this. If you don't have a centralized feature store right now, how many different rulers are secretly measuring your data in production?